All right, today we're going to talk about accuracy, precision, measurement, and significant figures. This right here is the most commonly used thing to describe accuracy and precision. We have a target with marks on it. First, I want to define the two terms. Accuracy is how close a measurement is to the actual value, or how close you are to the bullseye with your data. When you're precise, what that means is you are consistent, meaning your data comes in close groupings. And we're going to look at these and say whether or not they're accurate, precise, neither, or both. So if we look at the black groupings, that's obviously accurate. You've hit the bullseye. And it's all in a close grouping. The data is very close to each other. Bullseye marks are very close to each other, accurate and precise. If we look at the green markings, those show that they're very consistent, but they're not accurate, so they're precise, not accurate. The blue markings, however, definitely not consistent. So there's no precision there, but if you actually looked at where their average spots came out to, they would be accurate. However, I would not rely on that person on my team. Similarly, looking at the data, if we look at these two sets, if this was with the first machine that I used and I was recording the mass of something, and I got 3.52 grams the first time, 3.53 and 3.51, those are all really close to each other. So that's very consistent, so it's precise. And if the actual value was like 3.52, I would say it was very accurate. If you look at the second set of data, you have 3.20, 3.86, 3.50. Those aren't consistent at all. And I would say that this instrument has no precision, or very poor precision. But if you actually average out the values, you would get 3.52. And if that was the true value, it would be accurate. However, this machine, I would not trust with my life. This one, say it was even, the actual value was like 3.8, and it was consistently below. That is a systematic error, and it might just need some fine-tuning in the equipment. This, scattershot, don't trust it. Over here, we have an object, and we're measuring it with two different instruments or two different rulers. One obviously gives a greater level of detail. This one doesn't tell you anything past, or it doesn't give you any numbers past the integer place, whereas this one gives you to the 10th place. So if I were recording the length of this object with this first ruler, I would say it's obviously closer to 5 than 6. So you always approximate one digit when you're recording a measurement. So I would say it's almost exactly 5, so I'd say 5.0. If I were using this ruler, however, I would say that it's definitely between 5.0 and 5.1. So I would say it's 5.0 something. And then I'm going to say it's a little bit less than halfway, so I'll say 4. But this is off by a little bit. Usually we say the uncertainty in a measurement is 1 of whatever the last digit you're recording, for most glassware. There are some exceptions to that. So this could be any plus or minus 0.1. This could be plus or minus 0.01. This one obviously gives you a greater level of precision. So when we're talking about precision in measurement, it can mean consistency and the level of detail with which you know a value. So both of these numbers have zeros in it, but not all zeros count. They only count when they're between other significant figures. So if I took the number 8,005, both of those zeros tell us some level of detail about a measurement. So they both count. Any zero after a significant figure and after decimal counts. If I told you that something weighed 50.0 grams, you know that it's not just somewhere between 40 and 60. It's 50.0. 3 levels of detail. And then any zero immediately preceding a decimal, every once in a while you'll see it. There's a difference between 500 with no decimal, basically means anything from 450 to 550, whereas if you see the decimal there, that tells you that both of those zeros count. That's all.